This is a review for the final exam in COMP360 Programming Languages at North Carolina A&T State University. The final exam in COMP360 is on Tuesday, May 5th from 10:30 to 12:30. You got to be logged onto Blackboard at that time. The final exam will use Examgol, as we did in the second exam. It's a mix-up of several other languages. If anything is not defined, you can then say it works exactly the same as it does in Java. In Examgol, there are no brackets, no semicolons. Like Python, it uses indenting to determine the level of nesting. Methods start with the word function, or unless they're a constructor method, they start with the word constructor. Here is an example of Examgol and an equivalent Java program. You notice several minor syntactical differences. One notable thing is that variable declarations in both variables, local variables, class instance variables, and parameters start with the variable name, a colon, and then the data type. Pretty much everything else works just like it would in Java. In fact, as a rule, if it doesn't say otherwise, then Examgol works the same way that Java does. Should I put Examgol on my resume? You can be pretty sure you will never see it again. Different types of languages, in particular theoretical languages, which bleed into real-life languages, can be recognized by different types of theoretical machines, which also can be implemented by real machines. Regular expressions can be recognized by deterministic finite state automatas, or by a program that simulates a DFA. Regular expressions are very useful for describing the scanning process of a compiler. The parsing process, which is usually described by BNF for context-free languages, can be recognized by a push-down automata or a program that implements a push-down automata. Context-sensitive languages can be recognized by a bounded Turing machine, and a full Turing machine can recognize recursively enumerable functions, which are as complex as we can compute. A finite state automata is a bunch of circles and arrows where the circles represent a state and the arrows are transitions. There is a current state which tells you where you are, along with a start state that tells you where to start. The only memory that a finite state automata has is its current state, and then there's the input of the character which you read one at a time. Based on that input character and the current state, the finite state automata goes to a new state. During the transition, it may also take some action. And when you run into the end of the input, then the finite state automata may or may not be in a final state. If it's not in a final state, then it fails. Here's an example of a finite state automata. It starts on the start state here, and then accepts different characters. You can say if it gets an A, it stays in this state. If it gets a C, it goes over to the state to the right. If it gets another A, it goes back to the first state. If it gets a B, it goes back to the same, and so forth, until finally, if it gets into the double circle state, which indicates a final state, it stays there. There are several stages in compiling a language. In COMP360, we paid particular attention to the lexical analysis, the scanning, and also the parsing, the syntactical analysis. After that, there's a semantic analysis that determines if the language meets all the requirements, optimization, code generation, and then the linking. The scanner, which is defined by a finite state automata, reads in the source code and outputs a list of tokens. That list of tokens is then the input to the parser, which is driven by a BNF, a Bacchus-Norform description of the language, and it outputs a parse tree, which is the input to the semantic analysis, and so forth. So for our purposes, we particularly aimed at the lexical analysis scanner, which read the source code, created the tokens, and which were then input to the parser, which in our case created true or false. Was it correct syntax or not? Which is also what a compiler does, decides whether it's correct or not. And if it is correct, it creates a parse tree, which defines the execution order of the statements. A BNF, or Backus-Naur form, defines a language, a context-free language. It's just used by the parser. There are two major parts. There are terminals and non-terminals. Terminals are tokens or symbols that come in from the lexical scanner. They're all the punctuation and numbers and other items that the scanner picks up as a single unit. And then there are non-terminals, which is variables that the language uses to represent concepts and patterns. These never appear in the actual language. And the whole BNF describes a grammar. There are several parameter passing paradigms that can be used by various languages. Pass by reference passes an address or a reference to the variable. Java uses this for complex variable types such as objects and arrays. Pass by value is used by Java for simple data types that passes a copy of the value. If you change it, it doesn't change the original. Pass by value result is something similar to pass by reference. It passes by value, makes a copy, and at the end copies it back. There's subtle differences between that and pass by reference. Pass by result is there's no input value. When you're done, you pass the result back. Pass by constant value is used in C++ or C, and you can pass by value, and you cannot change the value. And then pass by name, which is used in some scripting languages and also by Snowflake. It's not very rarely seen anymore. The stack methods use a stack to save the variables. Not all computer systems use a stack, but most of them use a stack or simulate a stack. There are several things that are put on the stack. On our example here, if you start from the bottom up, first thing it pushes on the stack are the parameters to the method. And then it'll execute a call statement which pushes the return address. That is the next line after the call, so the compiler knows where to come back after you call the method. And then it creates an activation frame. It tells you what are the local variables and the information about this method. These are linked together to allow you to have a trace back in case of an error. And then all the local variables are done on the stack. So everything is kept on the stack. While local variables and parameters are allocated on the program's stack, dynamically acquired memory is from the heap. Dynamically acquired memory is like new. When you go new and you create a new object, or when you allocate memory like in a malloc from C or C++, this memory is taken from the heap. Now, some languages, such as C++ and C, they will require you to maintain that. In other words, when you acquire it, you can use it, and then at the done, you must free it. If you don't free it, it can stay there forever. Now, this has the advantage that it's very high efficiency and it gives the programmers exacting control, but you have to do it correctly. If you free an object too soon, you get an error. Some other pointer may reference it and try to use it when it's gone. If you free it too late or never, you waste space. Usually with a large complex system, it's not uncommon for things to be acquired and then never released. As the program runs, it gets bigger and bigger because there's objects being acquired and never released, even though they're unreachable. Garbage collection provides automatic memory management, so you don't have to free memory. It happens automatically. This makes it easier to program, eliminates the advantages of errors we just mentioned. It's used in several modern languages such as Java and C#. Of course, the big challenge is making it run efficiently. There are what they call parallel garbage collectors that run in another processor or in another core. So as your program is running in one core, the garbage collector occasionally starts and runs in the other core. I like garbage collecting. It's so much easier and safer than manual memory management. we can define the 4 pillars of object-oriented programming. Inheritance is the ability to extend or inherit from an existing class. Encapsulation allows you to define an object and accesses only through the defined inputs and outputs, such as methods. Abstraction is you can hide the inner details of how something works and allow it to operate in a more abstract way. And polymorphism comes in a couple different types. It allows you to modify, or the methods can morph depending on the type of input or request to them. Again, polymorphism, the ability for operations actually depend on the type of data being given to it. So you could have method with the same name, same return type, but different types of parameters. If you call it with a string, it works one way. You call it with an integer, it works a different way. Here's an example of polymorphism where you've got the method doIt, and one version takes a triangle object and does this, and the other version takes a square object and does that. And so in the example here, you can call it with both a triangle and a square, and it will do this or that depending on the type of objects you pass to it. Here is an example of subtype polymorphism. In this example, we have the class animal, and it has a talk method. So do the 2 child methods, tree and branch, that extend animal, and they both have talks. And then over here in the main program creates 2 objects of a tree and a branch, and then calls the let's here. Let's here calls the talk method on that animal object. Now it has to determine dynamically during runtime which talk method you want. Did you pass it a animal object, a tree object, or a branch object? So it has to know which talk method to call. Encapsulation allows you to restrict access to the inner workings of the object. In other words, you cannot directly access the variables used by the object. You can access them only through the interfaces that's defined, the get and set methods and other methods you might have that you can define to be visible to the outside. You can also define methods that are not visible to the outside. This way, the programmer and the compiler can be sure that these objects will not be changed by some external force. Abstraction is similar to encapsulation. It allows you again to hide the inner workings of an object. It does what you define it to do, and the actual method by which it does that, the variables used, the algorithms, can be changed without having to change the programs that use it. Here's an example of constructors, calling constructors. We start down here in the main method at the bottom, and we create a BAS object. So that calls the constructor here, the BAS object. Notice there's no parameters. And so this BAS object, which inherits from fish, has no call to super, so there's an implied call from this to the constructor for its parent, fish. So it calls the fish with no parameter. And you notice that this constructor calls this, or the same objects constructor, but the version that has a parameter. So it calls the version with minnow, so it's going to print them. So we passed it the word fish, so it's going to print fish, and then it returns, and it will print the word trout, and then this constructor is done, and this one returns back to bass, and it will print out the word bass. So it will be fish, trout, bass. Be sure you can do this in Examgol. Examgol works exactly the same as Java. There's override and overloading. Overridden is when you create a class with exactly the same name, the same number of parameters, and the same type. So the method call looks just like that. When you write a method, it overrides it. In other words, the parent method is no longer available, and you'll always use the child method when you call that method of that object. Here's an example where we have the plant class, and then it's extended by the tree class. The tree extends plant, and it has a branch method. Both plant and the tree have a branch. So in this case, they both take doubles. It's void branch and takes a double. It's overriding it. The tree method overrides the plant method of branch. And it's exactly the same. So if you create an object of the tree type and you call branch with either a double or an int, since there's no int version, it will promote the int to a double, and it always executes the trees version of the branch method. So it'll be tree2 and tree7. Then there's overloading, which is very similar. Overloading is a polymorphism when you create the same method but with different types of parameters, different number of parameters or different types of parameters. In that case, Java will select the appropriate method based on the type of parameters, the number of parameters it is called with. Overloading is very similar in it. Again, the method name is the same, the return type is the same, but the parameters will be different. In this example, again, we have the plant class and the child tree, which extends plant. They both have branch methods, but in this example, on the tree, it has a parameter type of int, where the parent class has a parameter type of double. So down in our main method, where we create a pine or a tree object called pine, and we call the branch method with a 2 with an integer, it calls the integer version. That is the branch method of tree. When it calls it with a double, there is no double version for tree, so it uses the double version of plant. So it produces tree when you call it an integer and plant when you call it with a double. We did a lot of functional programming with Haskell during the class. As the name implies, functional programming executes functions. It doesn't have iteration because you can't change a variable. So you couldn't iterate until a variable hits a certain value. It uses recursion instead. These are what they call pure functions. They have no side effects. They don't change the input values of the variables. It produces just a return value. You can also pass it a function as a parameter. This is a first-class function. In Java, you can't pass a function another function. Remember how to specify the data type or the signature of a function. In this example, sum square, we go num a, which is a represents a number type. That could be a float or double or int, and it's going to take an array of ints and return a single int. Again, here's an example of the method where we're going to use recursion to go through the list. There are other ways and simpler ways to execute this function if you use guards. And again, you can split those complex types of parameters. In other words, if you put parentheses, variable, colon, variable, then the first variable becomes the head and the second variable becomes the tail. And so when you define the method, if you use, in this case, the variable cat, you get the head of the input variable string. If you use dog, you get the tail. You can make multiple definitions of a function. In this case, the parameter is given as a constant, which is an empty string. And that says in this method, it's going to return a 0 if it's an empty string. And here, we've split the input list to the head, cat is the head, and dog is the tail. So all we have to do now is do the same thing as the previous function. It's just multiply cat times cat, which is multiplying the head of the string times the head of the string, plus we cursively call sum square on the tail. A much clearer function written in this form. You can use guards, where we have a calculated value, and if that's true, if the guard is true, then this is the function definition we use. This is a very simple function definition which returns a constant. And there's an otherwise statement, which if none of the other guards are true, then we execute this function. Again, a very simple function. Here's a method where we have a where clause. The where clause works with the guards. Where we calculate values or kind of local variables in a sense, depending on the input parameters, and then it simplifies the guards that use that variable. Okay, on the final exam, there are several questions you're likely to see. You will have to write a Haskell function, maybe a couple of them. You need to determine whether a given string is accepted by a BNF, or for a scanner, if that is accepted by a deterministic finite state automata. You may be asked to write a recursive descent parser method. And then we'll ask what will be displayed for the several examples you showed in the review here, for subtype polymorphism, for constructors, calling this and calling super, and then when you have overloaded and overridden methods. Be sure to understand Examgol, because several of the examples will be written in Examgol. You can bet they're going to be on the final. Be sure to review these topics. And of course, do the course evaluations for all of your classes. Give an honest evaluation for all the courses. The administration really counts on this. The final exam will be on Tuesday, May 5th, from 10:30 a.m. till 12:30 p.m. in the afternoon. You must be logged into Blackboard during this time.
Good luck on all your exams.
Contact Dr. Williams if you have any questions. Hey, online teaching and online learning ain't fun, but we made it through it.